we are having a new topic, that is absolute maxima and minima, or we are going to tell it absolute maximum value and absolute minimum value. Basically these are on the closed intervals. Okay, so before proceeding in the depth of the topic, let's go for the definition part first. Now for definition, first let it be for absolute maxima. Okay, a function f is said to be, we are going for absolute maxima, is said to be absolute maxima on an interval I at x0, any point at x0 if fx0 is the largest value of f on I. If fx0 is the largest value of f on I, on the given intervals, okay, on I, that is, now what we can write it, that is fx0 is greater than is equal to fx for all x in the domain of f that are in I. So what this is called, this is absolute maxima. It is absolute maxima. Now we are having absolute minima. Okay. A function f is said to be absolute minima. Now absolute minima on an interval I at x0 if fx0 is the smallest. Earlier there was a largest value, now is the smallest value of f on I, that is, now what it is here, that is fx0 is less than is equal to fx for all x in the domain of f that are in I. Okay, so what we are having now, absolute minima, absolute minima, absolute maxima, absolute minima. Now the important one is one more thing we have left it, that is, now what is, if f has either absolute maximum, if f has either of the absolute maximum or absolute minimum, on I at x0, then f is said to have an, then f is said to have an, now what the term is called? Absolute extremum. The term is called absolute extremum. Okay, on I at x0. So this is the definition. Now I will just be explaining you with some graphical parts, and then we will be proceeding for the theorem part. Okay, so this is a definition for absolute maxima, absolute minima and absolute extremum.